All right, today we're going to talk about line of best fit since we're finishing up scatter plots. So with scatter plots, we noticed that we had a bunch of data points and they didn't necessarily make a completely straight line, but they took us in a general direction of a positive correlation, a negative correlation, or they kind of looked just like confetti and there was no correlation. So before we get started, I want you, when you open up this document, to just look at these different scatter plots. I want you to say, what do you notice about each one? A line of best fit must hit at least two of the data points in a scatter plot, and it must go in the direction that you're seeing. So a positive correlation will have a positive slope. A negative correlation will have a negative slope for your line of best fit. So things that a line of best fit is not, you do not force it. So all of these data points are there's no correlation, and so we can't really draw a line of best fit. Also, you don't just draw a line of best fit wherever you want in the coordinate plane. It has to be in the general direction of all the points. So I'm going to have you fill in that slide completely on your own. Take what I've told you about line of best fit, what it is and isn't for the two boxes at the bottom, and just tell me, what do you notice about each of those four scatter plots? On the next one, we have two examples about snow cone sales and about gas mileage. So our first example, this is how we're going to make predictions. So when there are 150 people per square foot, how many snow cones can we predict will be sold per hour? So when we go to 150 people per square foot, I'm going to guess there's about 20 snow cones sold per hour. Because that's where my data point is. At 150, you're going right here, which is about 20. On the second example, when a car gets 30 miles per gallon, about how much can we estimate the car's price to be? So our price of the car in thousands and our miles per gallon. So when we have about 30 miles per gallon, we can estimate that our car is somewhere around $22,000. Because this time, we find the 30 on the y-axis, because that's where my miles per gallon is. And we're going to go to where do we see that data point? It would be somewhere in this general area, which is going to be around 22,000. And we have to go ahead and say 1,000 and not 22 because we have to read our units at the bottom. Okay, so let's talk through a few problems and how it would actually look. So with this, step one is to actually draw a line of best fit. Like I told you on the very first slide, a line of best fit has to hit two or more data points within your set or your graph. So let's see here. So if I draw, oh Lord, you're gonna have to just bear with me here for a minute. Those are all kind of in there. So there's my line of best fit. It's not the prettiest thing because it is on the computer and it's not the easiest to draw with. So then what type of correlation is this? Well, it is a positive correlation. All your data points are your shoe size is going up as your height increases. So what can we conclude from this? As shoe size increases, height also increases. So to have that positive correlation, both things are going to have to increase at the same rate. So let's practice another one. For this one, we have grades and attendance. So to draw a line of best fit, again, don't judge my little line we're going to be having. We're going to go from here. Okay, that really should be a straight line. However, we know that it's not the easiest on the computer. So what type of correlation is this? Well, since it's going down and it's decreasing, it is a negative correlation. So what conclusion can we draw? The more days you are absent from school, the lower your grade will be. Because that's what our graph is telling us right here, where we're like 0 to 5 days absent. The grades on our chart are like 85s and above. But as we get to 20 and 25 days absent, we're getting grades where they're below a 60. So let's look at this one. Draw a line of best fit. This is about grades and pets. This graph is like confetti, like I told you about last week. When it looks like confetti and the data points are all over the graph, there is no correlation. You cannot draw a line of best fit for that. So, too, what type of correlation is that? There is no correlation. And what can we decide from that? Your high school GPA, a GPA is a grade point average, and the number of pets you have are not related. So you could have 5 pets, and you could have a 4.0 GPA. You could have 0 pets and have a 1.0 GPA. The two things are not connected and do not lead from one thing to the other. Our next one. So this graph shows the total number of pages that Ben has read at different times during a 60-minute class period. These are some questions that we pulled from that are similar to things you'll see on quarterlies and EOGs, because we want you to be able to see that kind of thing too. Now, here's what I want you to make sure of. Before you do any work for a line of best fit problem, I want you to decide, does it have a positive or a negative slope? So I'm just going to go ahead and draw. Well, we're going to try to draw because my line was curving down. Okay, so there is my line of best fit. Is that a positive or a negative slope? It is going up, so it is positive. So automatically, I can mark out A and B because they both have a negative slope, and I know I can't have that. Now, to figure out my information from there, we're going to pick 2 data points. I'm going to use this one right here at 10:10. And I'm going to use, where's another data point? Right there is one that I hit at 30. And all I've done is write those down for you to see. So to create an equation from my data points, remember we find slope first. M equals y2 minus y1 over x2 minus x1. And in my ordered pairs, we have x1, y1, x2, y2. So when I plug in, I have 30 minus 10 over 30 minus 10. 30 minus 10 is 20. So 20 over 20 is 1. So when I go to plug that into an equation, when I plug into y equals mx plus b, I get y equals 1x plus b. So now I have to plug in everything else that I know. I'm just going to use the point 10:10. So 10 equals 1 times 10 plus b. 10 equals 10 plus b because 1 times 10 is 10. Now, to get b by itself, what is the opposite of positive 10? It would be negative 10 or subtract 10. If you do it to one side, you do it to both sides to keep your scale even. So my b is 0. So I would have y equals 1x. And remember, y equals 1x can also be written y equals x. So when I go back to look at my answer choices, I had y equals 2x or I had y equals x. So my line of best fit for this problem would be B. So on this problem, it says the scatter plot shows the height and circumference of some young trees. Which equation best models the relationship between the height and circumference of the young trees? Again, use everything that you know first. So I know that this, not sure what's going on there. this scatter plot has a positive slope. So I can automatically mark out B and D because they had negative slopes. So now I'm looking at A or I'm looking at C. I'm going to pay attention to my B values. I have a B value of positive 8 or negative 8. If I know my graph is crossing somewhere between 5 and 10, I know that's a positive number. So just using my context clues, I'm able to decide that my equation for this problem is A. I never had to find a slope. I never had to pick 2 points. You just use your context clues to eliminate what you know. Let's look at one more together. So this graph shows the amount of money earned by students after several hours of babysitting. So we have your babysitting hour or time and your amount earned. So which equation would best fit the data? Before we can do anything with trying to create an equation, we have to decide on some data points. So they've got some marked for you. They didn't tell you, but there's an exact point, and there's an exact point. So my coordinates, I have 2, 4, and I have 6, 10. Jump back over here and show you again. So first thing is we find my slope. M equals y2 minus y1 over x2 minus x1. When I plug in, I have 10 minus 4 over 6 minus 2. 10 minus 4 is 6. 6 minus 2 is 4. And when I simplify 6 over 4, my slope is 3/2. So I'm going to take that slope and plug it into my equation. So y equals 3/2 x plus b. And I'm just going to use 2, 4 because it has smaller numbers. So 4 equals 3/2 times 2 plus b. So 4 equals, when you multiply 3/2 times 2, you're doing 3 times 2 is 6. 6 divided by 2 is 3. So 3 plus b. To get b by itself, the opposite of positive 3 is minus 3. 4 minus 3 is 1, so 1 equals b. So my equation is y equals 3/2 x plus 1. So we would come back over to our document, and we would say y equals, and I'm going to put it in parentheses just so you can tell, 3/2 x plus 1. And then our very last slide, this cheat sheet slide, is all about some reminders for y-intercept and slope, because I know these are things we haven't done in the last few weeks. But remember, y-intercept can be called a starting point. It's your one-time fee. Where is it on the x-axis? It's where you begin. Slope, just like you've learned in the last several years, has lots of names. It's a unit rate. It's a rate of change. It's your change over time. So I hope that going through this step by step with you, you were able to keep up and find some useful information. So now that you've watched the Edpuzzle, you're going to go in and actually fill out the slides for yourself.